Kia ora, Year 12 and 13. This is the second part of question 2 from the paper. So the first one is a merit question and the second one is an excellence. Okay, let's take a look at what we've been asked to figure out. Well, we've got 2m and m are my limits. And then I've got this integral here. And we're asked to find the value of m that's going to make that whole thing equal to 117. What I'm going to start off by doing is just integrating this, and then at the end we'll set it equal to 117. Now there's a couple of ways to go here. We can expand this out, which works fine. When I did this one with my class this year, that's how I did it. But the faster way is not to expand it and just to do backwards chain rule. And that's quite easy in this case. So I'm going to do that way first. I'm not going to do the expanding way because the video will get too long. But let's see what we've got. Well, we're going to have 2x minus m to the power of 3. I know that I need to multiply it by 1/3 to undo the impact of the 3, right? But as well as that, when we differentiate this, the derivative of the inside function is 2. So that means I need to multiply by 1/2 as well. And my limits are 2m and m. I'm going to take the constant out the front, so we'll have 1/6 times 2x minus m cubed, evaluated at those limits. Now you can just check that when you differentiate this expression here, that you need the pre-multiplier of 1/6, if you're not feeling too confident about that. Let's evaluate that here. So that's going to give me 1/6, big bracket, right, 2 times 2m, 4m minus m cubed, minus 2m minus m cubed, and that has to equal 117. So what have we got here? Well, we've got 3m cubed minus m cubed is equal to, what have we got, 117 times 6, so that's 702. I'm going to use a new slide to finish this off. Okay, we've got 3m in brackets, important, cubed, minus m cubed equals 702. So this is not 3m cubed, but 27m cubed minus m cubed is 702. So that gives me 26m cubed. So m cubed is 702 divided by 26. M cubed is 27, and so m equals 3. So it's a really nice answer too. Quite a straightforward problem, quite a nice question, just making sure that you know how to work with the difference between x being a variable and m just being a constant. Okay, and you can try that one, as I said, by expanding out first, and you should get to the same result, but there's a little bit more working. So now I'm going to move on to the excellence question. Okay, we're looking for the area between two curves, and we're told that that area here is 24. So before we dive in and start integrating, we've got two functions. We've got y is equal to k minus 1 x squared, and k is greater than 1. So that must be this function here, because we know it's an ordinary parabola, so an up the right way parabola. This one here is y equals 9 minus x squared. And the shaded area has got an area of 24. So by symmetry, area A has got an area of 12. Okay, so we'll just work with that. We'll work with half the area being 12. Now if we look at that, we know what this limit here is. This is going to be 0. We have to find this one, and it's not 2, because it will depend on the value of k. So to find that limit, we're going to have to figure out the x value where the two lines meet. Right, so let's take a look at that now. Where does that match? What have we got? Well, we've got k minus 1 x squared equals 9 minus x squared. So k x squared, expanding out, and then adding x squared to both sides is equal to 9. That gives me x squared is equal to 9 over k, and we get x is equal to plus or minus 9 over k, which is plus or minus 3 over root k. But if we think about what we've got, this bad picture here, we just care about the positive x value because we're going to work with just half of that area there, so that lower limit's going to be 0. So now we're good to go, just about. We need to work out the top function minus the bottom function. So what will that give us? We'll just do a bit of algebra here before we start integrating. So we're going to have 9 minus x squared minus k minus 1 x squared. And that gives me 9 minus x squared minus kx squared plus x squared. So this is the thing we're going to be integrating. We get 9 minus kx squared, which is quite simple, really. I'm going to do the integration on the next slide. Okay, so here what we're going to have is the top limit will be 3 over root k here, and 0 here. And the expression that we're that we're integrating, right, the expression that we're integrating is 9 minus kx squared dx, and we know that that equals 12, right, because it's half of the area by symmetry. So we're going to have 9x minus k on 3 x cubed, 3 over root k for the top limit, 0 for the bottom, equals 12. And you can see already that when I substitute in 0, I'm going to get zeros popping out, so that's nice. So we have 9 times 3 on root k minus k divided by 3 times this equals 12. So 27 on root k minus, right, working with the numbers first, this is 27 divided by 3, so this gives me 9. I've got 9k divided by root k cubed equals 12. Now some of you will be thinking, why is she going so slowly? It's because I'm making a video for lots of different people, so if it's too slow for you, just fast forward. Right, on to the next page for the very last bit. So we've got 27 on root k minus all of that stuff from the last line simplifies to 9 on root k is equal to 12. 18 root k, collecting up like terms, is equal to 12. So 18 equals 12 root k, going very slowly, 1.5, I will even write 1.5. People in my class know that decimals are usually bad, but that's okay. 1.5 is root k, and so final answer, squaring both sides, k is equal to 2.25. Now I'm not